Good afternoon. My name is Samir Peshori, and I am currently a sophomore double majoring in computer science and information technology, while also minoring in business at NJIT. I currently have a startup that I am running alongside some of my closest friends on campus and hope to push forth with that venture upon graduation. We currently help assist local businesses with establishing and growing their online presence. We want to utilize this business model until we can earn enough to push into other areas. If the business is not what ultimately ends up working out for me, I am looking to also do my grad work in either data analytics or cybersecurity and go into either field respectively upon finishing my master's. In my presentation today, I will be talking about Intel's Optane memory, its benefits, effects on both consumers and corporations, as well as my thoughts about the product and its widespread availability and its impact upon all of us. In this day and age, primary forms of storage are comprised of mechanical hard drives and SSDs. Generation by generation, we are working to progress storage speeds to be comparable to that of main memory or even system cache. The issue, however, is the price of that storage. Faster speeds are what are desirable to every person, but with that comes a price tag as well. Just some time back, even the current mainstay of SSDs were once well out of most people's budgets. Even now, Intel's Optane memory is mainly used just for OS files and not even a main form of storage, at least on the consumer side of things. However, its growth and evolution will redefine what we currently view as the norm in terms of read and write speeds, and that also for forms of memory that are available to the consumer side of things and also to bigger corporations that require such forms of these storage units and will change the mainstay of what we use. Intel's Optane memory, to at least the consumer side, is offered as an M.2, SSD, and PCIe card, compatible only with specific Intel Core processors, those of the 7th generation or higher. It comes in at 16 and 32 gigabyte variants that are used as cache solutions, or even a pricier 375 gigabyte Optane SSD version. In this sense, it can achieve super low latencies, even as low as 10 microseconds. SSDs were once based on NAND flash, which was used to store data. Optane is now based on 3D XPoint and is faster than any of the NAND SSD options on the market as of now. Now, Optane can be viewed as a hybrid between mass storage options, such as SSDs and hard drives, or even faster memory options, such as a computer's main memory, because it is not only similar to memory in low latency times, but also to larger storage options for the amount of data it can hold. Optane is also stronger in sustaining these low latency speeds, even under a bulky load, and in result it can make it a go-to option for server and cloud-based operations and/or services. Both Optane and conventional storage solutions operate in completely different ways. For an Optane, data can be accessed at the bit level, while the others access data at the block level. This allows for Optane to modify individual bits instead of what typical NAND solutions have to do, which is completely overwrite this data to modify it, making for its write times to be significantly slower. Hence, Optane's write times are quoted to be 10 times faster than that of even SSDs. Optane is also consequently able to operate just as fast when it is getting slammed with the load, unlike other storage solutions. Also, even at low capacity options like its 16 gigabyte variant, with the new XPoint technology, it is able to perform relatively well. In terms of differences between Optane and DRAM, DRAM operates as a volatile memory source, which is a short-term option and requires constant power to keep data stored in its memory. When the PC is powered off, DRAM will lose all the data that it had stored, unlike Optane. Optane paralleled with DRAM, however, can be very helpful because it can act as a next-in-line storage solution between DRAM and normal storage, but also have the ability to store data even when Optane loses power. In terms of compatibility, Intel's Optane memory is compatible only with Intel's processors from the 7th generation on. Users must also be wary of the compatibility of their motherboards, as they must also be Intel Optane ready and have the UEFI BIOS. Also, the user must be aware if the given vendor of the motherboard and its compatibility with Optane memory is there. But most of the popular motherboard manufacturers, such as ASRock, Asus, EVGA, Gigabyte, MSI, and more, support Optane memory. Windows 10 is also currently the only supported operating system to utilize Intel's Optane memory. It is currently not available on Linux and or Mac OS. With Optane's availability, as mentioned before, for the general consumers, Optane is available as a cache solution in either a 16 or 32 gigabyte variant, or even as a mainstay storage solution in the 375 gigabyte SSD variant. For the commercial side of things, however, Optane is more readily available as a mass storage option, but with a heavy price tag at the same time. In this case, though, operations like cloud-based and server work become a lot more efficient. For example, there is a company called Aerospike, which is a database platform, and it was able to test Intel's Optane memory as a NAND flash and DRAM replacement. And with its aid, they were able to have their databases run a lot faster on Optane over conventional NAND flash-based options. This is due to the fact that they were able to utilize it in an environment in which Optane was used like RAM, not exactly as RAM, for in-memory processing, or like an SSD for caching or hot storage. Just as SSDs were once just barely even affordable, at even low-size options to general consumers, the same is now also happening with Intel's Optane memory, until it could become a more widespread storage solution. Now, SSDs are everyone's go-to, as Optane will be in the future only. This will allow private researchers and such to go about implementing their work and algorithms at even faster paces on their personal machines once Optane becomes more widespread. Even in the current market, however, a 280 gigabyte Optane SSD costs around $260, which is the price of a pretty decent GPU actually. The performance increase is also significant to the point that only enthusiasts at the moment would consider purchasing Optane to boost their system read and write times. For the general consumer, this is still not a very practical or viable option to go forth with, unless if they just choose the cache options just to enhance OS operation and main file operation. In terms of Optane's benefits, Intel claims that its Optane DC P4800X SSDs can have write speeds that are 10 times and read speeds that are 3 times those of conventional SSDs. Even solely using the 16 or 32 gigabyte cache solutions can greatly improve day-to-day use, since vital OS files can be stored on them permanently to offer faster boot and read times. Even keeping video game save files on these cache-based solutions can improve read speeds while loading in between levels when playing, making for a more seamless experience. The reason for this speed is due to the fact that Optane is on a faster memory bus than that of a conventional SSD or mechanical hard drive. And due to these especially fast write speeds, Intel was able to heavily contribute to cloud functionality. Like in IBM's example, Optane was able to improve their servers by 7.5 times in their speeds, especially for applications that have heavy write speeds. Optane was also able to assist the University of Pisa by helping them achieve a 4-minute MRI scan, as opposed to their traditional tests in MRI scans, which averaged at 42 minutes, which saves a lot of time in their processes. My take on Optane at this point in time is that it is not going to sweep the consumer space, but it will be a viable option for data centers or research centers doing heavy algorithm work that requires especially fast write times. Only now have the prices gone down in any way for both the SSD and M.2 variants of Optane, but I believe they are still out of the reach of the general consumer. As a cache solution, however, for the 16 and 32 gigabyte variants, I feel that Optane can be best used in this manner for consumers like us. They can really make an impacting difference if one still uses a mechanical drive, for example, and needs their access times to be increased right away. If one is using an SSD, though, I believe it won't be necessary for them. Just keeping a good quality SSD as a primary drive with enough storage on it, in my opinion, would be more than sufficient for the average user. The difference between read and write speeds between a normal SSD and Optane will be negligible for day-to-day tasks for most of us. However, for bigger companies with more intensive tasks, they can see great benefit in using Intel's Optane memory. And until the prices drop down, everyone could continue to use an SSD and then make that transition over to Optane as we did from mechanical hard drives to SSDs in the past.